My name is Joern Barthel. I'm one of the co-founders of Kreuzwerker GmbH. And today I want to talk to you about building a smart platform permission management strategy specifically for AWS. And smart in this case means something that is easy to do, but still extensible enough. So what's a platform anyways? For me, you build a platform as soon as you introduce some standards into your organization. And in this sense, a platform is basically a contract between an organization or sub-organization and its members, where we decide upon certain aspects of governance that we want to have in our platform. For instance, choosing from operational excellence an observability toolkit, or implementing a cost strategy, or implementing certain security strategies. Maybe there's also some compliance aspects that we need to consider. Building a platform is about enabling your users while sticking to guardrails. And for that, of course, you need some kind of permission management strategy. What do you want from your permission management strategy? You want, first and foremost, to protect your governance rules with guardrails, right? So you want to protect the integrity of your platform in the sense of that you can still be sure that these guardrails that you put in are respected. You want to be able to attribute actions to your users, so figuring out who did what, maybe even why. And of course, you want to be able to keep all kinds of entities away from stuff. You want to keep computers away from stuff. You want to keep people, internal and external people, away from stuff. And that stuff usually is data and compute. The principal technology that you're going to reach for when building a permission management strategy on AWS is going to be IAM, Identity and Access Management, specifically IAM policies. But the concepts introduced with IAM are hard and complex. So principles, so the things, the entities that can act on things enabled, empowered by policies, principles are already a complex thing. And the identities that are behind those principles can also be chained. So you can assume a role as a principal, and that role may be enabled to assume another role in another context. So this is already quite complicated. Policies are very, very powerful, too powerful, I would argue, too powerful to implement a permission management strategy just using these tools alone. So just let's have a very, very quick look on what policies are. So we have a lot of different types of policies. We have identity policies, which are associated with an identity or a principal. We have policies that are resource-based, so associated with a resource like an SNS topic or maybe an S3 bucket. We have permission boundaries, which are a policy concept that can be used when applied right to prevent a principal that is capable of creating other principles to have more permissions in this new principle than that principle had in the first place. We have service control policies that can be applied to organizational units of accounts or to AWS accounts. We have ACLs, access control lists, which are another kind of permission management scheme that is available in some services. We have session policies, which are transient policies that can be applied to temporary credentials acquired by assuming roles. And we have a little bit of magic as well in some kind of resource policies like KMS key policies and grants. So KMS key policies are not really affected by the policies that, for instance, a principal brings to the table. So a principal that has an administrator kind of role will still not be able to interact with the KMS key unless the KMS key specifically, so the resource policy on the KMS key specifically says that this person can interact or this principal can interact with it. Since the effective permissions are basically the sum of all these policies that apply to some resource or to some kind of interaction, we end up with a Venn diagram from hell. So it's really, really difficult to figure out the effective permissions. And another problem that makes managing with policies alone is that the policy size limits that apply to all of the policies in play here make things like pursuing an allow listing strategy really, really difficult. So consider you use the standard that That is the de facto standard when dealing with IAM policies. Deny listing, and AWS creates a new feature or a new service, and maybe this new feature in the service you've been using all along is really, really powerful, and you want to restrict that. With deny listing, you will not catch it, and allow listing is, in most cases, not really possible because of the limits, of the size limits to policies. You have other powerful features like conditions and functions on conditions and variables that can pop up in your policies. Depending on the service, there might be different variables available. Depending on the identity providers used, there might be different values that match to these condition context keys. You can also introduce other powerful concepts like attribute-based access control, where you kind of have dynamic policies built with conditions, most likely on tags, where the actual effective permissions depend on the attributes being passed down from your identity provider to your principal. For instance, membership in an organization or membership in a department or something like that. And of course, there's a lot more. The debugging landscape is pretty complex for effective permissions, and especially when you deal with variables and conditions a lot. There are different states of implementation for tags when dealing with attribute-based access control. Some of the actions support different classes of resources that can be applied to, etc., etc. But despite all this power, there's still lots of limits and policies. So, for instance, you can do a lot with EC2, but you cannot restrict relatively simple things like editing certain resources in a DNS zone, for instance, only. So what can one do? One alternative is to use more accounts instead of less policies, so pursuing a multi-account strategy. And the multi-account strategy basically boils down to, from the policy end, to do whatever you want, but only in specific accounts. That basically means introducing organizational units, so collections, tree-like collections of accounts, and workload accounts specific to the permission strategies that you pursue. On the right-hand side, you see a little tree, which is an example for such an organizational layout coming straight from the AWS multi-account strategy best practice paper. The additional benefit, of course, of introducing multi-accounts is that you have a very easy cost attribution story. You don't need a complex tagging mechanism for that. You can simply say, okay, this and this amount of money occurred in cost in this and that account. And you do not share limits between accounts for things like EC2 API requests. Drawbacks, of course, service integration between accounts is more complicated, and there are a bunch of cross-cutting concerns like support plan management that become more complicated. Tooling for this is free and built into AWS. That's AWS Control Tower and implicitly AWS Single Sign-On and AWS Organizations. With AWS Control Tower and AWS Single Sign-On come centrally managed principals and permissions out of the box. So in an ideal world, you would not even define principals in AWS, but pull or push them from some kind of IDP via SAML. This is very easy to do, and almost all organizations nowadays have some kind of SAML-enabled IDP in the form of their email provider. From this vantage point, you can now centrally manage, distribute roles, and together with these roles, permissions as well, and map users and groups to accounts and these roles in the form of a concept from AWS Single Sign-On called permission sets. The integrity protection for this configuration is provided by Control Tower, and this is a very, very easy way to centrally manage the permissions when pursuing a multi-account strategy. You still need some kind of customizing in your multi-account strategy still, because there are a bunch of missing links now. You want to be able to create and protect shared infrastructure or configuration still in the setup. This is, of course, a little bit out of scope for this talk, but there might be things like network controls or shared network structures, or maybe shared pipelines, etc., that you want to distribute over your accounts. But privilege escalation is a thing. So When you have principals that can do whatever they want on these accounts, then they will be able to create new principals like IAM users or maybe IAM roles. And these may or may not have permissions that are strictly greater than those that the principal originally was supposed to have. Or maybe allows things like persistence. So after a colleague was kicked out of Google Workspaces, maybe this person will still be able to log into the accounts using some kind of role they deployed there at some point. So central customizations are still needed, and the recommendation to get started with this is really just using AWS CloudFormation stacks and stack sets. And stack sets is basically a technology in CloudFormation to be able to deploy stacks to a series of accounts, organizational units, a mix of, or just completely dynamic using lambda functions. There are also frameworks available for that, like the customizations for Control Tower solution, AWS Deployment Framework, and AWS Org Formation, all open source. But there are even, I would say, simpler schemes. So one example is to try to shift a little bit away from policies to more reviews. An example study workflow for this, again, with CloudFormation, looks like that. You distribute, still on the account basis, read-only-ish permissions, so more or less read-only except for certain things that you might want to not make available for people, maybe certain log files. So you distribute read-only-ish permissions for the whole account, and then you allow the creation of CloudFormation change sets with a service role. So service role basically means that CloudFormation acts as its own principal. So CloudFormation in this case has the ability to create all sorts of stuff. And change sets are basically a change mechanism. So you manifest the changes for creation or modification of stacks, but you still need to execute them. And now you restrict the execution of change sets to review roles. So only people who are in the reviewer group perhaps can execute a change set, but only those change sets that they didn't create. Very, very simple policy. And now you gain the ability to review and approve change sets via command line, or maybe if you want to build a little bit of tooling via Slack. Tooling for that, my recommendation would be to just use TypeScript and CDK. CDK is a very, very, very simple way to get started with CloudFormation. I would say it is the way to use CloudFormation nowadays. And together with TypeScript, it's also a very, very friendly way to get started with CloudFormation. So in closing, I would recommend to really try to write complex scenarios or to complex policies only for scenarios that are really well defined. And of course, just working with an AWS account is not really well defined. So when you have a bunch of SOPs, like really specific scenarios where you need to work with maybe high stakes resources, complex policies are your friend. The other thing about policies is that I would recommend to rely on the policy mechanism where the effective policy is easy to understand in isolation. So KMS key policies are great for that, because whatever you put in the key policy, it's clear that no administrator type principal with an appropriate identity policy will be able to do things with the encrypted resources, the KMS encrypted resources, unless they are part of the key policy. And the other mechanism that is quite easy to understand are policies expressed in service control policies, because they simply apply to the whole account and cannot be overridden by larger identity policies or resource policies. And last but not least, as discussed on the last slide, try to rely more on review mechanisms, specifically managed review mechanisms. So review mechanisms that you don't build your own, because then there's a little bit the question of who watches the watchman, or who has an eye on what the super privileged builders of that mechanism are doing. So rely on managed review mechanisms instead of trying to regulate every interaction, and then try to catch issues in review instead of trying to catch every violation at runtime through a complex policy. Keep in mind the contract. You as an organization want to safeguard certain things, maybe due to compliance or just for governance reasons, but you want to enable your users, you want to enable users to build fast. Thanks a lot. and have fun building platforms.